This is my fish. His name is Pascal. Why? Because Pascal is one of my favorite people. Not the fish, this guy. Blaise Pascal. Hey kids, it's Algebra 2 time again. Today we're going to look at how to expand a binomial, and we're going to get help from this nice Frenchman named Blaise Pascal. What did he give us? Well, he gave us a triangle that we looked at in class today. All kinds of neat numbers arranged in pretty cool ways, and we talked about this in class, and if you need to, you can refer back to your notes as far as how Pascal's triangle works. What we're going to use Pascal's triangle to do is to expand a binomial expression. So here I have x plus y to the 5th power. Now instead of writing out x plus y times x plus y times x plus y times x plus y times x plus y and foiling a lot, there's a pattern that we can follow instead. And we can use part of Pascal's triangle to help us out with that. Now if I'm going to expand this binomial to the 5th power, I know that if I'm expanding it to the 5th power, there is going to be 6 terms. Those 6 terms have coefficients that I can find in Pascal's triangle. Right there. As I expand this binomial expression, my 6 terms will start with the coefficients that I see there from the 5th row in Pascal's triangle. I start with a 1. The next term will have a 5 for a coefficient. And the next will be a 10. And the next after that another 10. And then a 5. And then finally a 1. Each term, then, is also going to be included here. I take the first term, x, and I'm going to start with x to the 5th power. The next term, I'll have x to the 4th. The next term, x cubed. The next, x squared. The next, x to the 1st. And finally, x to the 0 power, which is 1. In each term, I will also have the second term of my binomial, in this case y, but in this case, the exponents will increase. Starting with y to the 0 power, which is 1. No need to put it there. And then I have y to the 1st. And then I have y squared. And then I have y cubed. And then I have y to the 4th. And finally I have y to the 5th power. Now when I'm expanding these, I can go ahead and put a plus sign in between all of the terms because I'm adding these 2 terms here. So my final answer, if I wrote it using one color, would look like this. X to the 5th plus 5x to the 4th times y plus 10x cubed y squared plus 10x squared y cubed plus 5x y to the 4th plus y to the 5th power. Now that's not so bad. But what if the terms in our binomial had coefficients of their own? Well, if we take this step by step, I think we can handle it. This binomial is raised to the 4th power, which tells me that there are going to be 5 terms. The coefficients of those terms will still include the numbers from Pascal's triangle, in this case the 4th row, as you see there. Here's how I would set this up. I know my coefficients will have to include a 1, a 4, a 6, a 4, and a 1 based on Pascal's triangle. Then I'm going to take the first term, which is instead of being just an x is now a 2x. Well, that first term in the first term of my expansion is going to be raised to the 4th power. Notice how I put it in parentheses to remind myself that not just the x is raised to the 4th power, but the 2 as well. That term will be cubed here, squared here, raised to the 1st power here, and finally to the 0 power, which is 1 and unnecessary in the last term. With the second term then, 3y. I won't worry about the negative for just a second, so hang on to that idea if you're going to ask about it. 3y to the 0 power is 1. I don't need to include it in the first term. 3y to the 1st goes here. 3y squared here. 3y cubed here. And finally 3y to the 4th power. Now since this was a difference, I'm subtracting the 2 terms. The terms in my expression will go back and forth between being positive and negative. The first term was positive 2x raised to the fourth power. That will continue to be a positive term. The second term, I have 3y raised to the first. Now if I figure that this is a negative 3y, negative to the first power is negative, I'm going to go ahead and put a minus sign in front of that second term. My third term, the 3y is squared, so if you want to think of it as a negative 3y squared, that would become positive. This term in general is positive. The next one, odd degree, negative. The last one, even degree, positive. Now that I have all the terms set up correctly, the last step is to simply multiply all the coefficients together where applicable. My first term, 2x to the fourth power. Well, the 2 is raised to the fourth power, which is 16x to the fourth. The next term, minus 2 is cubed, which is 8 times 4 times 3 is going to be 96. X cubed times y. The next term, 2 is squared, which is 4. 3 squared is 9. 4 times 9 is 36. Times 6 is 216. X squared, y squared, of course. The next term will be negative. I'll put the minus sign there. 4 times 2 is 8. 3 cubed is 27. 27 times 8 is 216. X times y cubed. And finally, 3 to the fourth power is 81. So my last term is going to be 81y to the fourth. And there you have it. Your final answer in this video tutorial on expanding binomial expressions. So you can consider yourself blessed.